Okay, guys, we're going to try this again. I've already written the notes down, so hopefully you guys can follow along. And this time I'll use my handy dandy orange pointer. It's my favorite color. So my orange pen, and we'll talk a little bit about today's notes. You do have a quiz. It'll either be tomorrow or we'll give it to you as a take-home for the weekend. I'm not quite sure what we're doing yet. But please don't plan on it being a take-home, and then you show up and you say, but you said, no, I didn't. I said it may be. I just want to give you an idea that that's what I'm thinking about, so that way you put it in perspective, okay? But anyway, here we are. We're talking about factoring polynomials using a graph. So you have a graph here, and you notice that it's crossing the x-axis in 4 places. These 4 crosses of the x-axis are the x-intercepts. One thing to note, and hopefully someone has talked to you about it before, that x-intercepts are also called solutions. They're also called roots. They're also called zeros. So anytime we're talking about those as far as a function is concerned, we're talking about the same thing. So we've got an intercept at -3, 0, another one at -1, 0, another one at 2, 0, and another one at, that's a 4. I know it kind of looks like a 9. My apologies. That is actually a 4. So please don't put that down as a 9. But I have an x-intercept at -3, one at -1, one at 2, one at 4. If I write those down before I solve them, we're looking at x plus 3, x plus 1, x minus 2, x minus 4. Remember that the factor, it's typically x minus h equals 0. So the h value is positive. The minus is always going to be there. Multiplicity. What does multiplicity mean? There are 3 types of multiplicities. There's linear, where the graph as it passes when it has the x-intercept appears to be linear. It appears to be a straight line. There's quadratic, where when you have an x-intercept, it appears as though the function takes on a quadratic nature around that intercept. And lastly, there's a cubic function, where it looks as though it appears to be cubic in nature. That's its multiplicity. So, what's the multiplicity here? Well, the multiplicity, since it looks linear, is 1. Multiplicity here is squared, because it looks quadratic, so it's a multiplicity of 2. And this guy is a multiplicity because he looks cubic, a multiplicity of 3. Last but not least, this guy does look linear, so he has a multiplicity of 1. So we have multiplicity of 1, 2, 3, and 1. That gives us factors, because that's to the first, there's going to be 1 factor. That's going to be squared, so there'll be 2 factors. This one will give you the quantity x minus 2 cubed, which will give you 3 factors. And lastly, this one will give you x minus 4 to the first, which will give you 1 factor. So the polynomial, if I was to actually write it, or based on the sketch, it would be the quantity x plus 3 times the quantity x plus 1 squared plus the quantity x minus 2 cubed plus the quantity x minus 4. Yes, you can do it if you want to just make sure that everything is negative to positive and in increasing order. You could write it like that. There would be no problem with that. There's nothing wrong with the way it was written before. But some folks just get a little... They got to have it just so. So turn the page over, and we get to this guy. And this is just kind of a telling way that there is at most n zeros, where n is the highest polynomial, or the highest degree of the polynomial. So if we have a 7th, then it's 7. There's at most n factors, so because it's 7, there's 7. N intercepts, 7, 7. And n minus 1 turning points, or humps. So n minus 1 would be 7 minus 1, which would be 6. Now let's go back and take a look at this. This guy, as far as turning points go, if we were looking at it, it would have at most 1. If we look at this as far as the factors go, we have 1, and then 2 is 3, and then 3 is 6, and then 1 is 7. Would you agree with that? Hopefully you would. So if we take a look at this function here, we can see that we would have 1, 2, 3, 4, potentially 5, depending on how crazy this guy would be. And then 6. So we could have 1, 2, 3, 4, 5, or 6, depending, once again, if this guy takes on a crazy shape. But we do have at most n minus 1 degrees, so it would be at most n minus 1 turning points, or humps, so to speak. So I do want to do one question on here really fast. So let's take a look at number 1. So if we take a look at number 1, first thing I know is that I have an x-intercept at 0. I have an x-intercept at -3. And I have an x-intercept at at positive 4. Okay? Now, this is a first, second, third, so this is a cubic function. So in my mind, I should be thinking it operates like this. Okay? Now, because I have an a value that's negative, it's going to look like that. So, this guy right here to the left, he's going to go from infinity to this function. Now, it's linear in its approach, so it's got to look linear. So it's coming down through it linearly, if that makes sense. At x equals 0, or I'm sorry, at negative x, it also is linear, so it's got to look like a straight line. And then at x minus 4, or at positive 4 here, it's also got to look linear. So how do we do that? We just simply connect those dots here and here. So, does it look like a cubic function? You bet it does. Does it look like one that's been reflected over the x-axis? Yes, it does. Is my left end behavior positive infinity and my right end behavior negative infinity? You betcha. And does it appear to be linear at the intercepts? Yes. So that is how I would sketch the answer to number 1. Hopefully that was helpful to you. We're going to be getting into, I tell you what, let's take a look at number 6 real fast. I think we got time to get number 6 in, and then we can be done. If I'm going to graph this, I'm going to first have to factor it. So I factor it the way I normally do, and I'm left with x squared. I will end up with x squared minus 1, and then x plus 2, which then gives me x plus 1, x minus 1, and then x, that's an x, not a t, sorry, x plus 2. So if I'm graphing, once again, I have one at -1, I have one at +1, and I have one at -2. It's 1, 2, 3, it's cubic, and my a is positive, so that means it's x to the third, and it's positive, so it's going to take on this look, if everybody can see that. So that means I'm going to infinity from here, I'm coming from infinity from here, and they're just going up, and coming down, and coming back up, and there is my sketch. And once again, that's exactly what it's looking for. It does say to graph them, and it wants some sort of fancy thing, but I'm just looking for a sketch that you know what it looks like and how to change one from the other and the other one back again. Hopefully this was helpful. We will get into the pages of the other stuff as we get into our flipped classroom tomorrow. Remember, it is early release. You do not get lunch, so if you want to bring something light to class, I don't care. Just make sure it ends up in the trash can. And then after you're done with class, you go to 4th block, and then you go home. Thank you so much. Have a wonderful day.